Hello guys! Today I will show you how to understand the Jeppesen airport chart. So here we have chart 10.9 for Vilnius International Airport in Lithuania, published on 2012, January 27th. On the left we can see the airport elevation of 646 feet above the mean sea level, and below that we can see the coordinates for the airfield reference point. Now below that we can see three frequencies, one of them which is for Aerodrome Terminal Information Service 125.8, Lit Cargo's handling 135.75, which is the ground handling, and Vilnius Tower 118.2. Below all of this we can see a beautiful map for the area surrounding the airfield and the airfield itself. In the middle we can see the runway 20 with a course of 195, and on the opposite direction runway 02 with a course of 015 degrees. And around the runway, of course, we can see the whole apron with a few taxiways, for example Foxtrot, Foxtrot 1, Echo, Delta, Bravo, and so on. We see a big rectangular shape, which also says for parking positions C10, 9A, which we will see a little bit later. Around the airfield we can see a lot of markings for woods and for obstacles, and for the obstacles, of course, we have their elevations marked. For example, there is a tower just a little bit east of threshold runway 20 at 700 feet above mean sea level. Right next to this marking we can see, of course, the runway length, 8,251 feet or 2,515 meters. Then there is an indication for VOR, the omnidirectional beacon. To the right and up of that we can see the variation, 07 degrees east, and left, right, up and down of the map we can see the coordinates. On top of that, right here you can see some information regarding the runways, regarding the runway length, slopes, that taxiway Foxtrot is for aircraft with wingspan of up to 36 meters only, that there are birds in vicinity of the airport, and below that for the whole map you can see the scale. Below the map you have the additional runway information section. On the left you have the runway lighting systems, which say, for example, for runway 02 you have high intensity runway lights, you have centerline lights, and you have high intensity approach lighting system number 2. You have runway end identifier lights, sequenced flashing lights, touchdown zone, has a precision approach path indicator. And you can see that there are circled numbers 1, 2, and 3. Well, these give additional information about the lights. For example, that the high intensity runway lights have a spacing of 60 meters, or that the precision approach path indicator is angled at 3 degrees, and so on. To the right we have the usable lengths for the runways 02 and 20. For the threshold we have really no information because there is no displaced threshold. For the glide slope we have 2,181 meters for runway 02 and 1 meter more for runway 20. This means that if we touch down with the glide slope, we have this length remaining for our roll. And for the takeoff you can see that there is a number 4, and for that we go a little bit lower and we check the distances from the certain points. For example, from the start of the runway we have 2,515 meters from taxiway Echo or from taxiway Delta, well, according distance. And here we have the width of 164 feet or 50 meters. Below all of this information we have some information regarding the low visibility procedures, which basically tell you how are they done, what are the minimums, especially below for the takeoff. It says that low visibility procedures must be in force and gives you the limitations regarding the operable lighting systems. For example, right here in the second column you can see that if you have operable high intensity runway lights and centerline lights for aircraft categories A, B and C, you need 200 meters of visibility for departure. For category D you need 250 meters of visibility and so on. Okay, now let's go to the next chart. 10.9a, published 2012 January the 27th for Vilnius International, which is the ground and terminal chart. Here you can see the whole terminal area with all the stands and taxiways, for example stand 50, 49, 48 and the taxiways Lima, Mike, November and so on. Of course some additional information where you have the terminal itself, where you have the control tower with all the airdrome information service and meteo, where you have some hangars, and that the chart is not to scale. In the left and down part of the chart we have a big square for INS coordinates. This would be used for IRS or INS alignment for the aircraft according to their stand positions. For example, for stands 1 through 3 we have coordinates north 54, 38.7 and east 25, 16.9 and so on. And on the bottom part of the chart we have some additional information about which stands are equipped with entry guidance system, well, that taxiing from stand 46A under own engine power is not permitted, and another additional information which is associated with parking and taxiing in the terminal area. So the next chart would be 10.9 Bravo, which was published 2003 May the 30th, which is about the stand entry guidance system. So first of all we have some general information. How does it look like? What does it consist of? Below that we have the information about azimuth guidance for nose and stands, which basically tells that if you have a, for example, if you have a right green light and left red light, you would need to turn towards the green light to the right. If you have both green lights, the aircraft is on center line, and if the green light is on the left and the red light is on the right, you have to turn towards the green again to the left. And there is a stop marking board, which basically tells you when or where to stop the aircraft when parking. Okay, now moving to the next chart, which is 10.9 X-ray. And it is the GAA minimums, published 2011 November the 4th. And I won't be talking too much about this chart because basically all it does is list all the minimums for approaches into runway 02 or 20. Well, the examples of approaches are category 2 ILS, ILS with approach lighting system out, localizer and also with approach lighting system out if we need it, our nav approach, VOR approach, NDB DME approach and NDB approach. And for example, let's take runway 02, localizer approach minimums. They are 1020 feet above the mean sea level or 426 feet above the ground and 1300 meters of horizontal visibility for category A aircraft. Should the approach lighting system be out, we would increase the meteorological horizontal visibility by 200 meters to 1500. And this is all basically the same for all of the other approaches. Now, after having checked the general information charts for the airport on the ground, let's go to something a little bit more difficult, which is the standard instrument departure chart. So here we have 10-3, which was published on 2010 December the 3rd and effective from December the 16th for Vilnius, Lithuania. Below the upper part we have again a frequency, Vilnius approach 120.7. We would contact them right after departure. We have again the airport elevation, 646 feet above the mean sea level, and some additional information. Transition level will be told by ATC, while transition altitude, where we change to QNH 1013 standard or QNE, 5,000 feet above mean sea level. And then the information that we have to contact Vilnius approach when passing 2,500, and that we should go along the nose abatement procedures according to ICAO document 8168. Below that, we have the list of departure names which are listed in this chart, which are Ducat 1 Alpha, Lavor 1 Alpha, and Uten 1 Alpha for runway 02 towards northeast and the east. Right of that, we have a circle with 2,700 feet, and this is our minimum safe altitude, with the middle point being the Victor November Oscar or Vilnius VOR. Now below the list, we see a procedure for lost communications. This basically says that we have to follow our standard instrument departure, but we have to play a little bit with our altitude. We have to continue to our last assigned altitude or flight level and continue climb to planned flight level. And then we have to leave the last assigned flight level at earliest 7 minutes after it is reached. This is so that the airfield air traffic control would understand that we have lost our communications. And then below all of that, we have the general map for the standard instrument departures, which is not to scale. So let us, for example, look at Uten 1 Alpha departure, runway 02. So after departure, we would fly a heading of 015 degrees straight and continue straight ahead until passing 7.8 DME from Victor November Oscar, which we have to do at or above 3,000 feet as seen here. After that, we would turn left to a heading of 354 degrees magnetic towards 33.4 DME of Victor November Oscar as seen here. Afterwards, we proceed direct to Uteno. And of course, as for any other waypoint in the chart, below the waypoint identifier, we have the coordinates, which for Uteno would be November 55 to 7.7 and East 025 26.6. Additional information we have is that Uten waypoint is on a radial of 359 degrees from Victor November Oscar as seen here, at a distance of 49.9 nautical miles. Well, the information would be generally in the same format for any other departure, maybe with a few minor differences. And now, below the whole map, we have some information. For example, that these standard instrument departure routes require a minimum climb gradient of, and they say that it's 401 feet per nautical mile. That is 6.6% up to 4,000 feet. Above 4,000 feet, it can be a little bit lower. So according to our ground speed in the table here, we can see what would be the climb rate per minute to achieve the 401 feet per nautical mile. For example, if our ground speed is 100 knots, we should achieve 668 feet per minute. Now, if enable, of course, we have to inform the ATC, and below all of that, we have an information for our initial climb, which says climb to 4,000 feet unless otherwise specified by the ATC. all understood. And we can go a little bit below just to see the general summary of the routing for the standard instrument departures. We were looking at UTEN-1 Alpha, and we can basically see the same what I told you. On runway track, trying to Victor November Oscar, 7.8 DME, turn left, and so on. This wouldn't be much different with any of the standard instrument departure charts you might find, except maybe the number of departures, the directions, the number of runways, and things like that would be different. But the general information given is the same. So thank you very much for joining me in the Understanding Jeppesen Charts Part 1. I hope that now you have a little bit better idea. And in the next part, I will show you the approach charts and the landing charts. Bye!